This lesson is going to work through limiting reactant solution stoichiometry problems. As with all solution stoichiometry problems, you start with writing the balanced equation. So we need to see what it is, in fact, that we have. Calculate the mass of lead 2 sulfate. So we know that lead 2 sulfate is going to be SO4 for sulfate. Lead has, sulfate, remember, has a -2 charge. Lead has a +2. So when I'm working with this here, I know that that can work out to be PbSO4. And that precipitates when 1.25 liters of 0.05 molar lead nitrate, lead 2 nitrate come together. So lead 2 nitrate, nitrate, remember, is an NO3 with a minus charge, and lead has +2. So in this case, that's going to be PbNO3(2), and 2 liters of 0.25 molar sodium sulfate. Sulfate is SO4 minus 2, sodium is Na+, so that works out to be Na2SO4 are mixed. So the first thing we need to do is write the equation and figure out which one of these are going to be the reactants. So it looks like these two substances are being mixed. So we can say that lead nitrate is going to be mixed, and remember, because it's a nitrate, it's aqueous, with sodium sulfate, which is Na2SO4. Because of that sodium, we know that's aqueous as well. And then it tells us that we've made lead sulfate, PbSO4. For this one here, the sulfate is actually going to be solid because of the exceptions. And we have, as our other solution, sodium nitrate. So we need to check whether or not these are balanced. And it looks already that we have one lead here, 2 sets of nitrates over here, but only one here. And also we have 2 sodiums. So by putting a big 2 here, that should balance that part out. And it looks like everything else is balanced. So there's our balanced chemical equation. So now let's identify what information we have. So for the lead nitrate, it tells me that I have 1.25 liters, which is my volume, and I have 0.0500 molar solution, which is my molarity. For the sodium sulfate, it tells me that I have 2 liters, that's my volume, and 0.0250 molar solution. And what this is looking for is the mass. So we are looking for grams of sodium sulfate that have been precipitated out. So in this case, what makes this unique in this eliminated reactant problem is that, do you notice how for your reactants you have all the information? That means we need to figure out which one of these reactants is going to run out first and base that answer on which reactant will run out first to give us our product. So this brings us back to the BCA table. So for the BCA table, remember, you can always only be working with moles. So we'll start off with our equation, PbNO3(2), and then we have Na2SO4, PbSO4, and 2 NaNO3. Okay, so let's create these lines. As I said, it only allows you to use moles. Can I get from these liters into moles? And if I look at my schematic over here, if I have a volume, using the molarity, I can get to the moles. So we'll follow this path for both of those reactants. So in this case here, I'm going to have 1.25 liters of PbNO3 times, and then molarity, remember, is 1 liter, and 0.050 moles. So this will allow me to cancel that out. And when I do that calculation, my calculator tells me that I have 0.0625 moles of PbNO3. I'm going to do the same strategy over here. I'll do it on the side. Remember, I want to get this value into moles so I can use my BCA table. And using my schematic, it tells me that if I take the volume and times it by the molarity, I can get my moles. So that's 0.0250, 1 liter, 0.0250 moles. Sorry that I'm not labeling these as appropriately, but it allows me to use less space. Okay, and so that works out to be 0.5 moles. Okay, so I see that it has to be a 1-to-1 ratio. There's 0 now. So in this case, that's an easy enough situation because this clearly shows that there's less Na2SO4 than there is PbNO3. Remember, it should be a 1-to-1 relationship, so all of this is going to be used up, leaving us with nothing. We're going to use up 0.05 moles of PbNO3, leaving us with 0.0125 moles of leftovers. And in this case, again, it's a 1-to-1 relationship. So that means I have 0.05 moles of PbSO4 produced overall, and I have 0.10 moles of NaNO3 produced. So it's asking for how many grams of precipitate. Remember, this is my precipitate here, in which case I just convert that into grams. So 0.05 moles of PbSO4, and then I just take my molar mass from the periodic table, and that's 303.26 grams, giving me the answer of 15.16 grams of PbSO4. So that answers that question. Calculate the concentration of all the remaining ions. So in that situation, when we work through that, what we want to do is we want to figure out how many ions still exist. And in that case, you look at these ions over here. We're talking about the spectator ions. And in that case, well, we would have to say that we still have .1 moles of Na in our 1 liter solution. And let's actually just skip that. I'll work through that in class because I can tell that's going to get us a little bit too complicated. We'll deal with that later on. Okay, and that works through a limiting reactant problem. You're welcome to try now example number or letter C and see what you're working through there.